In this video, we will learn about ohmic and non-ohmic resistors. Let's understand about ohmic resistors. Ohmic resistors are the resistors which strictly obey Ohm's law, and VI graph, that is potential difference and current graph, for which is straight line passing through the origin as shown in the figure. So all the ohmic resistor will follow this graph. All metallic conductors such as silver, copper, aluminium, nickel, iron, tin, etc., metallic alloys such as nichrome, manganese, constantan, brass, German silver, etc., and mercury are ohmic resistors, which means they follow Ohm's law. Ohmic resistors are also known as linear resistors because VI relationship for them is linear one. So here we have the graph for Ohm's law, and all the ohmic resistors follow this graph. Now let's understand about non-ohmic resistors. Non-ohmic resistors are those resistors which do not follow Ohm's law in true sense, and VI graph for them is non-linear one. Here we can observe the non-ohmic resistors, fluorescent tube, PN junction and vacuum tube do not follow Ohm's law, and for them the graph is not linear and it is non-linear one. Fluorescent tube, CFL, LED lamp, PN junction, transistors, solar cells and electrolytic solutions are common examples of non-ohmic resistors. Non-ohmic resistors are also known as nonlinear resistors because VI graph for them has any other shape but a straight line. Here we can observe the same thing. So all these have other shape than a straight line. Hence, these are non-ohmic resistors, also known as nonlinear resistors. Now let's understand the factors on which the resistance of a conductor depends. So the resistance of a conductor depends on first, length of the conductor, second, the area of cross section of the conductor, third, the nature of the material of the conductor, and fourth, the temperature of the conductor. Let's discuss these factors one by one. The first factor is length. Temperature and cross section area remaining constant, the resistance of a wire of given material is directly proportional to its length. So mathematically we can say that resistance is directly proportional to length. That is, on increasing the length, resistance also increases. If the length of a wire is doubled, keeping other factors unchanged, then its resistance is also doubled. If the length is tripled, the resistance is also tripled, and so on. Next factor is area of cross section. Temperature and length of the conductor remaining constant, the resistance of wire of the given material is inversely proportional to its area of cross section. Mathematically, we can write that resistance is inversely proportional to the area of cross section. That is, if we increase the area of cross section, the resistance will decrease. If the area of cross section of a wire is doubled by taking a thicker wire, then its resistance is reduced to one half of its previous value. If the area of cross section of wire is half by taking the thinner wire, then its resistance is doubled, and so on. The resistance of a conductor depends on nature of material of the conductor, and for a metallic conducting wire, the resistance increases with an increase in its temperature. So on combining the above results, we can say that at a given temperature, resistance of wire R is directly proportional to L by A, or R is equal to rho into L by A, where rho is the constant of proportionality. Here the symbol is pronounced as rho and is constant of proportionality, and its value depend on the material of the conducting wire. The constant ρ is known as resistivity or specific resistance of the material of the conductor, and it is the characteristic property of the material. Now let's understand about resistivity or specific resistance. Resistivity of a substance is the characteristic property of its material on which the resistance of a substance depends. For a wire of length L is equal to 1 and area of cross section is equal to 1 of a given material, we have R is equal to rho into 1 divided by 1, which is equal to rho. Thus, resistivity or specific resistance of the material of a conducting substance is mathematically defined as the resistance offered by the substance of that material having unit length and a unit cross-section area. Alternately, resistivity of a material is equal to the resistance offered by a unit cube of that material for the flow of current across its opposite faces. The resistivity of a substance is a characteristic property of its material and is independent of its dimensions. Resistivity or specific resistance, that is rho, is equal to resistance into area of cross section divided by length. Thus, the SI unit of resistivity is equal to ohm meter square divided by meter. This meter will cancel out this one, and here we get the unit of resistivity, that is ohm meter. Thus, the SI unit of resistivity or specific resistance is ohm meter. For a circular wire of cross section having a radius r, the cross sectional area is A is equal to pi r square. We know that resistance is equal to rho L by A. Here we can replace this A by pi r square, which gives us rho L by pi r square. So here we have it. Next, we can replace this r by d by 2. This is because radius is equal to diameter divided by 2. So we get that rho L by pi, instead of r we can write d by 2, and here we'll write square, which gives us rho L divided by pi d square, and here we have square of 2 4, which can be written over here. So we get 4 rho L divided by pi d square. Thus, we can say that for a given length of wire of given material, the resistance is inversely proportional to the square of its radius or diameter. If radius or diameter of wire is doubled, then its resistance is reduced to 1/4 part of its original value. Here we have electrical resistivity or specific resistance of some substances at 20 degrees Celsius. First category is of conductors, that are metals. Material is given over here and resistivity is given in ohm meter. So silver is 1.60 into 10 to the power minus 8. Copper is 1.62 into 10 to the power minus 8. Aluminium is 2.63 into 10 to the power minus 8. Tungsten is 5.20 into 10 to the power minus 8. Nickel is 6.84 into 10 to the power minus 8. Next is iron, which is 10.0 into 10 to the power minus 8. Platinum, which is 11.0 into 10 to the power minus 8. Chromium, which is 12.9 into 10 to the power minus 8. Next is mercury, which is 94.0 into 10 to the power minus 8. Then we have manganese, which is 184 into 10 to the power minus 8. The next category is of alloy, which is manganene 44 into 10 to the power minus 8, constantan, which is 49 into 10 to the power minus 8, then is nichrome, which is 100 into 10 to the power minus 8. Then we have semiconductors, First material is germanium having 0.4. Then we have silicon which has 2300. Next category is of insulators. First material is pure water 2.5 into 10 to the power 5, dry paper 10 to the power 12, glass 10 to the power 10 to 10 to the power 14, diamond 10 to the power 12 to 10 to the power 13, hard rubber 10 to the power 13 to 10 to the power 16, ebonite 10 to the power 15 to 10 to the power 16. So these were some of the materials and their resistivity in ohm meter. I hope this topic is clear to you. Thank you.